What if everything you needed to take your data from its raw form to production-ready quality existed in one place? You'd prevent so much of your business's value from getting lost in translation. Michael Berthold, CEO of NIME, highlights data management's pivotal role in developing a roadmap to responsible AI, right here on Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanagh here. And folks, I am very excited to have, frankly, a legend in the industry with us today. We're going to be talking with Michael Berthold. He is the founder and CEO of a company called NIME. That's spelled Knime. And they are an open source analytics and data science platform, a visual platform for doing data science, which is good stuff because even though there are lots of people who can code very well, almost anyone can look at visuals and move boxes around on a screen. So that's what they figured out. So with that, Michael, welcome to Inside Analysis. Tell us a bit about yourself and NIME and what you folks are working on these days.
Thanks for the invite, Eric, and having us on the show. As you already said, NIME is very much about visual programming, low code for data science, and we started that many years ago as a platform, really as a workbench almost at my group at the University of Constance, to be able to kind of deploy our research results to the real world, to practitioners wanting to use that. And it's grown from there to become one of the only open source visual data flow platforms for doing anything you want to do with data. And I mean, I'm always a little bit careful about calling it data science because that often scares people because they say, oh, I just want to do data wrangling. I don't care about the sciencey bits, and that kind of scares them off. And that's what NIME does as well. So a lot of applications that we see in real life is just, in large air quotes, just getting data in the right shapes from many different sources.
Yeah, and I will tell you, I'm a huge fan of open source. In fact, we built a website a number of years ago, and we feed it with a technology that we built called Media Lens, and it's called Inside Open Source. And the reason we launched it was because I realized there's so much happening in the open source world. There's the Apache Foundation, there's the Linux Foundation, there are lots of other projects outside of those organizations as well. But in the origin of open source, I found fascinating. So I first started researching this in 2005 when I was working for the Data Warehousing Institute as their web evangelist. And Katrina had just struck New Orleans. I just moved out of New Orleans, so we watched it all happen on TV. And it was just, of course, terrifying. But I remember that the senators from Louisiana asked for $250 billion to rebuild southern Louisiana. And I happen to know through a past life and past clients in the government space down there that the politicians are good at making money disappear. And I thought to myself, this is a very bad situation because if all that money just floods in, it's going to flood right out, not where anyone intended, and a lot of it is just going to disappear. So I went on this high horse, if you will, and started doing research, and it took me to open source. And I put forth this theory about open source government, about publishing all the government data such that citizens can see where the money goes and understand. And I basically said, look, with the Sarbanes-Oxley Act in the States, which came out of the Enron debacle, corporations had to document their processes for how they come up with their numbers. They had to be very transparent about that stuff. And I thought, well, if corporate America has to do it, why doesn't the government do it as well? And people thought I was crazy. But a couple things happened that were amazing. One guy paid attention. Out of 40,000 people I emailed, one guy paid attention, and he worked for the Heritage Foundation. He went and he basically testified to Congress and said, we can have citizen auditors, this stuff really can happen. And he really leveraged the imprimatur of TDWI. And sure enough, they did it. House passed a bill, Senate passed a bill, co-sponsored by a guy named Barack Obama, who was a senator for Illinois, and then President George W. Bush, believe it or not, signed the Federal Funding Accountability and Transparency Act in September 26, 2006. And I almost fell off my chair. I was like, wow, they actually did it. But the reason I bring this up is to talk about the power of open source. And I realized at the time, the Apache web server had just surpassed the Microsoft web server as the #1 web server. And I thought to myself, well, that's very interesting. And I was also studying service-oriented architecture at the time. And I thought, Well, if you have all this open source code and you have a service-oriented architecture, you should be able to plug and play and sort of take stuff out and put stuff in and have a very composable environment. And I thought, well, that's not going to be very good news for the SAPs and the Oracles of the world, because they like the monolith, they like control, and they have control of all that stuff. And it took longer than I thought, but about 10 years later, open source just blew up the market with Hadoop and with Kafka. And of course, you have KNIME. So tell me a bit about the open source foundation of KNIME and what drove your decision there, and what it means for your customers.
That's a very interesting story. I didn't know about that open data movement coming from Katrina back in the old days. So KNIME is a bit atypical in its open source models. I mean, fundamentally, there are really three different ways to do that. You can have distributions like Linux, and you're essentially making money by packaging them up nicely and supporting them. But essentially, there's not really new code that you're adding around it. Not quite true. I mean, they all have little installers and that type of stuff, but that's fundamentally the idea behind distributions. You can also have what people often refer to as open core, where you have something that you open source, but it's more of a teaser. It's more bateware. And if you really want to use this in production, you have to buy some commercial bits and pieces around it. And then you have, of course, also the MongoDBs that are essentially databases, that type of stuff. Also, maybe even a Databricks with Spark. They have really cool open source technology, and they make it accessible to you in the cloud for a charge. KNIME is different in that we have one open source piece, that's the analytics platform that allows anybody who wants to build these workflows and execute these workflows and pretty much do anything they want to do with data. And then we have a commercial complement software to that, which we call the KNIME Business Hub, which allows people to productionize that and collaborate. So when you have more than one person using the analytics platform in your organization, and you want to deploy that as a web interface or a REST service, or you want to collaborate and have compliance and governance kind of features, that's when you buy the hub from us. And the reason the open source platform is open source, the open source analytics platform is open source, is not necessarily, I'm not too religious around it, but to me, it's in the data science field in particular, you can't exist with proprietary software. There's so much cool new stuff going on a daily basis in research groups and other types of environments that you're essentially standing on the shoulder of many, many giants. A lot of functionality inside KNIME is actually based on open source libraries. So it seems kind of unfair almost to put that into a proprietary umbrella. And also it enables us, to be fair, to get make inroads into into teaching environments much easier, because they can just use the open source platform for teaching. But we have a number of open source contributors that are contributing additional functionality into the KNIME Analytics platform. So it's really, I like to see it as a win-win situation. Also for our customers, because they essentially get a lot of maintained functionality from us. In addition, they have access to all of those community functions out there.
Yeah, that's very cool. I mean, there are a lot of good things about open source. One of the things I've heard over the years is that bad code goes away because all these eyes can see. Now, the one shortcoming I've come across is that the open source project gets to MVP status, if you will, minimal viable product, and then doesn't typically go past that. Just because it works now, we just kind of move beyond that. But what are your thoughts about that in particular, about how you make sure that you have truly finished products and that you're able to deliver robust platform analytics ongoing for all of your clients? Like, how much effort does that take internally from your developers to stay on top of the platform and make sure everything's working?
That's a very good point. I mean, I tend to joke that 99% of all PhD projects turn into open source projects, and then they kind of die away and fiddle away and never really turn into something useful in production. Now, I'm probably about half of our development team. We have like 80 developers at KNIME, are focused exclusively on the analytics platform and just making sure that core works and works in a professional environment. We have our own extensions, which are of course maintained by ourselves, so we have the same quality assurance there. We have what we call trusted community extensions, where we're in close collaboration with the community, contributing those extensions, so we can also make sure there's quality assurance there as well. And then there is, I'd call it the long tail of extensions that are experimental, right? The nice thing is that everybody can use those and play with those and explore new technologies. And then when we see increased usage of some of these experimental extensions, we can move them into the trusted extensions as well.
Interesting. That makes a lot of sense. So you're trying out things. You've got these extensions in trials, basically, and then once you see there's a lot of activity, then you throw some developer support behind it to harden it, is the term we typically use, right? To make it sure that it's bulletproof, that it really does what you want it to do, et cetera. No, that makes a lot of sense. And you do end-to-end. NIME does everything from data ingestion, data pipelines, number crunching, model building, all that kind of fun stuff is in the NIME analytics platform. Is that right?
Yes, that's true. So we have everything from about the ETL part, loading the data. We can access about 400 different data sources. We can access databases, strange file formats, Excel, of course. We can also execute bits and pieces on different execution environments, like doing the ETL directly inside a database or in Snowflake or in Databricks or in Hadoop in the old days. And then we go all the way to visualization via the analytics functionality. And a lot of that, as I said before, is of course based on e-charts for the visualization, a lot of Python libraries, C libraries, R libraries, Java libraries for some of the machine learning functionality. We have integrations with TensorFlow if you wanted to do that. We have integrations with the other deep learning libraries. We have integrations with XGBoost. Pretty much everything is in there. But the other piece is, so often when people talk about end-to-end data science, they only mean this kind of from the data to the report or to the endpoint or to the model. But the business hub then also covers the rest of this journey, right? Deploying it to others, managing it, retraining models when needed, and monitoring their performance.
Well, right, because at the end of the day, you want these algorithms to connect into your business, whether it's for marketing or for manufacturing or supply chain or whatever it is. You want it to affect some outcome in the business. And so that involves connecting to operational systems, right? It involves connecting to ERP systems or CRM systems or things of this nature. That's where the magic happens. And a lot of times that's the hard part, right? I mean, I've heard many stories about models that just don't get deployed because maybe the company just didn't have the wherewithal or they didn't have the expertise to do it properly. But being able to plug the algorithms into operational systems and then monitor how those models perform and switch them out, right? Because you've got your production model and you have your challenger models that are sitting by the wayside waiting to get pulled in, and being able to switch over to a new model when a model that's in production starts faltering. That's a critical piece. And that, I guess, is that done in Business Hub with you folks?
That's done on the Business Hub side, exactly. So as Business Hub, you can deploy models which really are deployed NIME workflows. You can deploy them as a REST service or as a web application, and then people consume it, and you can constantly monitor what's happening in production, and then potentially replace, retrain, or just alert the data science team and just say, hey, this is so out of whack with reality, we don't really know how to fix that, do something about it. The nice thing is that you don't have to switch code in between, right? In the old days, it was always somebody coded the model, it was trained in some strange language, and then it was reprogrammed by IT into some production language. On our case, on the hub side, the workflow that was trained is also the one that runs in production.
That's interesting. So one of the other hurdles that people are running into is when they use Jupyter notebooks to write their model or to build their model to test with data, and then they want to go put that into production. And it's just this step-by-step tedious process of copying over code and values and all these things. And that falters often. That, from what I understand, is a really serious problem. But I guess, do you not have that challenge because you're not using the Jupyter notebooks typically, and people are just in the environment, in the analytics platform, building out their models after they pull in their data, et cetera? So you're already production ready when the process begins. Is that about right?
That's a very nice summary. Yes. So what you use on the creation side when you actually train the model is exactly that piece of the workflow gets then moved into production and executed by exactly the same engine. So you don't also have a translation issue there. The other piece that people often lose in this going from training to production is all of the feature engineering that you did, all of the feature transformations. You tend to lose them. So you only can take the model and move that in production, but you can't do the transformations. And in NIME, you can grab automatically the part of the workflow that has the transformations and the model, applying the model, take that, grab that automatically and deploy it to NIME Business Hub.
Talking to Michael Berthold. He is the CEO and founder of a company called KNIME. That's Knime. Look these folks up online. An open source analytics platform. It's wonderful stuff. It's like a giant candy store for analysts to go play and have fun. But I wanted to talk to you about these large language models, Michael, and in particular, first of all, the open source side of the equation. So Meta comes out with Llama and Llama 2, open source. OpenAI used to be open, now it's not. Now it's the ironically named OpenAI because it's a black box. And with the technology this powerful, I believe we need open source. You know, I don't know that I would get behind a mandate that they must be open source, but there needs to be some transparency into how these things are working, just so that we can have, our peaceful sleep at night to know that there aren't bad actors involved somehow. I mean, certainly for regulated industries like financial services, if you bring it into some workflow for loan approval or something like that, then you have to be able to explain how you came up to your answer. But what are your thoughts in general about open source versus closed source with these large language models?
I think there's a lot of value in it. The problem is that in my opinion, there's open sourcing large language models isn't just about open sourcing the code, but you also need to open source how it was actually trained. So in a sense, you also need to at least give open access to the data that was used for training. Because even if I give you a model and it was trained on half copyrighted material that it's going to spit out again when you use it, you wouldn't know if you didn't have access to the training data, right? That right. Part of that is was it supposed to be used? And then I think the other piece is that what some companies are open sourcing is only the code to use the model for predictions later, to actually apply it. You still don't know how it was trained. So that's the third element that needs open sourcing. And then I believe one of the key proprietary ingredients that a lot of these companies now have is safeguarding code around it, so that some types of answers don't get produced, some types of inputs aren't being accepted, and open sourcing that as well would really, really reveal their secret sauce. And I think that's why the OpenAIs of the world are shying away from that one.
Right. No, it does make sense. I mean, we have proprietary code. It's not new. But again, these are very, very powerful engines. And then there's another whole side of this equation, which is the RAG model, retrieval augmented generation, which upon great reflection, I believe will be the layer of functionality for governance, for privacy, to a certain extent for security, for management. You know, a lot of that's going to get baked into the RAG model, where you could, for example, before you hit your prompt, before your prompt goes up to the large language model, have a layer in between that checks and sees, okay, and this is already happening. Like I asked Gemini a couple weeks ago, how many electoral votes are in Georgia and Arizona and some other state, and it thought for a second and said, oh, elections are complex and fast moving. We recommend you use Google. Right? That is a guardrail. That's a guardrail. They clearly built that in to say, no, we don't want to touch that. Right. And that's in the RAG model, right? That's not like trained in the model. That's outside the model, but it's the workflow you have around the engine that's very, very important, right?
I totally agree with that one. I mean, that's what I called the safeguards before. And I think sometimes it's probably not even part of the context that's part of the RAG models, but it's really part of some safeguarding code even around it. I mean, we use that at KNIME as well. So we have built in what we call Kai inside the analytics platform that allows you to have a QA mode. You ask questions, how I do this and this in Excel, how does that look in a KNIME workflow? And then it shows you a couple of nodes in KNIME. And we're, of course, filtering that these nodes do actually exist, because every now and then OpenAI, which we use underneath the hood, hallucinates and invents nodes that KNIME probably should have, but we don't have it. And that doesn't help the poor user at all. Right? That's a very, very simple way of code around the Kai that is just making sure that what it spits out is reasonably useful.
Mm-hmm. Yeah, that's interesting. And you're going to see more and more of these AI agents. That's what everyone is talking about now, are AI agents, which are like little bots, semi-autonomous bots that can do various things, and they can check on each other, and they can do all kind of stuff. I mean, it's very interesting to me when we talk about data science. We talked about it before. It all seems to be getting subsumed now into AI and conversations about AI, even though there are lots of different versions of AI, right? I mean, there are traditional models, regression models, like all sorts of old-fashioned AI, if you will, that's still very powerful and still works. But the new stuff is sucking all the oxygen out of the room. Isn't that about right?
Yeah, we see that as well. And sometimes, I mean, I'm an old guy by now. I've seen this in the past, right? When backpropagation came along, everybody was suddenly using gradient descent for every problem. We just thought, hey, you can solve this directly. You don't need to do gradient descent. Then it was support vector machines, and then it was somebody else, and now then was deep learning, and now it's AI. So sometimes we see people building workflows for even very simple things. They're reaching out to some AI, and we just say, hey, there's a node in Lyman that does that. Computationally, a lot less expensive. I don't use that. So I think, to me, it's a bit of a hype right now. It's just a new kid on the block. Everybody wants to play with it and use it. But augmented, really mixing it and matching it right with traditional techniques, I think that's where the true value lies.
Yeah, well, and so I'm just guessing here that one of the nice things about your platform is that it is an end-to-end platform for building models, designing models, training models, pulling the data in, all these things, and it's adjacent to this business hub. So you have a marshaling area for ideas and for testing algorithms and for testing models. Then you connect it through the business hub and see what happens and see how it operates. And it's important to have this one environment where that takes place, because when you have multiple tools, it just takes longer and it's disjointed and there are connections between the tools and things change. So it's important to have that main marshaling area, to have your it's like a giant analytics sandbox. Is that about right?
That's a very nice description, absolutely. I tend to say that a data scientist doesn't necessarily need to know how the method does something, but it needs to know what the method does. So if it's reaching out to a Python library or an R library or a C library underneath the hood, it's not that important. But you still need to understand what the method actually does underneath the hood to be able to interpret the results. Simple example, if you don't know what a regression coefficient is, you won't be able to interpret it. But you don't necessarily need to understand how it was derived from the data.
Yeah, no, that's very interesting. Let me throw this concept at you and see what you think about it. I wrote up an article just last week, I guess, about this. I was flying to a conference in Denver, just thinking about these large language models and analytics and AI and all this stuff that I've been covering for a long, long time. And I thought to myself about this concept I call the executive cockpit. And the idea is that I think very forward-looking organizations are going to deploy a small language model that is aligned with their business, like if it's manufacturing or healthcare or whatever, on their data, in their data center, so on-prem, possibly in the cloud as well, but I have my thoughts wrapped around this on-prem small language model. Then you're going to train it on your ERP, on your Salesforce, on your CRM, on your customer support, for example, your tickets, like any of your core enterprise systems. You're going to train this model on your data, on your business data. Then what you'll do is set up Kafka topics coming from those systems into a vector database adjacent to this interface for the small language model. And that is where the executives will spend their day running their business, because then you could ask any question at all. How is our marketing working in APAC? Who can we let go if we have to save some money? Where are we weak in our organization right now? Just all kinds of different questions, and you'll get all these answers. And I actually mentioned to a CEO of this one company, because I was trying to get him to help me do sales enablement for them, because I have this big audience I've been marketing to for years. And one person turns out to be the next deputy chief data officer for the IRS. And I sent this email saying, hey, this is a lady I've known for a long, long time. This is what I mean by sales enablement. Do you guys have the IRS account? And he fired back. He said, I don't know if we have those accounts. And I thought to myself, well, you would know if you had the executive cockpit, because you would just ask it, do we have the IRS account? Who is the account rep? What's the latest in this account? Because you're getting information from all these systems in your private environment. But what do you think about this concept? Is that doable? Is that pie in the sky? Or what do you think about all that?
It's an interesting idea. I thought about similar. I mean, at the end of the day, you're personalizing a large language model around your own infrastructure, your own in-house data. I think the challenge there is that in order to get a really, really good model like that one, that's really useful, you need to train it on a lot more data than just your own. So in a sense, you need to benefit from your competitors' data without actually seeing that, but kind of learning the general structure and the general insights, and then you customize it on your own, which in return kind of means that you should also be providing your data to other other organizations. It's almost like that's kind of pre-competitive training of these models so that they're useful for everybody. I think just training it on your setup, you need some bigger context than that. Or maybe you're a giant company and you have enough context anyway. But for every small company, I don't think you have enough data to really get meaningful insights.
That's very interesting. That's a good point. Because I'm wondering to myself, and I'm going to throw this one at you too. So one of my aha moments with these large language models was when I realized that when you train them on a corpus of data, they're not actually persisting the data verbatim. It's not like they're taking strings of text and storing it in a record somewhere, but rather in the training process, that data you use will adjust the weights and biases and the parameters of the model. So in other words, it's like, well, that's very interesting that it can train in that fashion and then reflect back to you such remarkably granular detail about things. And what I've seen is that if there's a subject area that has been published about widely, like how computer processors work or how an irrigation system works, anything that has a lot of content on the web that these engines were trained on, it does very well. It knows all that stuff. It's when you get to the fringe of where there's not that much published, and I guess that's kind of your point about having enough data to train the models. If you don't have enough, you're not going to get the contours right, and it's going to be skewed in one direction or other. Is that about right?
I think that's a very good summary. The contours is right. I mean, a colleague of mine once summarized it and said, essentially, it's a consensus engine. It's getting the consensus around what a computer programming is, learns that from the data and can repeat that. But if it's just one isolated outcome, it's probably not going to be able to recall that one.
Interesting. Yes. So Craig Schmidhuber, I think his name is. He's the guy who wrote the papers on the transformers, and he's based. I guess he's actually in Saudi Arabia these days, but I want to say he's German, of German origin. And I was amazed when I realized he wrote those papers in like the 1990s or something. And it's just now we have the compute to be able to. Could you explain that? Is that what happened? Is that just the timing was right now to be able to understand this and put it into play? Because that was one of the big changes, and now it's able to see 10, 12 tokens left or right as opposed to just like 2 or 3. And you also have this, like you say, like a consensus, right? So there are I call it almost like an AI Greek chorus, where one is saying, I think it should be an A, I think it should be a B, I think it should be a C, and then the
exactly
goes, okay, I'm going to pick this one. That's very interesting. It's a very interesting development, but why do you think it took so long? Is it just because we now have the compute to do that?
I think it was a compute power issue as well, and then some science tends to have a little bit more of needs a little bit of time before it truly has an impact, but it was mostly waiting for compute power. I don't know, one way of looking at what this consensus really does is, I don't know if you watch these YouTube videos about ChatGPT playing chess.
No. And
the interesting part is that at the beginning it does extremely well and does very sensible things, and part of that is these opening libraries are all over the place. Right, so that's extremely well-established consensus. And then somewhere in the middle, it starts inventing bizarre moves, and suddenly new figures pop up on the board out of nowhere, right? And it has always meaningful explanations for that. And the problem there is that data is so sparse that there's no consensus to learn. So at the beginning, it almost looks like it understands chess rules, but the only reason it does follow the chess rules is that they're so deeply ingrained in all of the common material that you see, that the likelihood of going outside of the rule book is too small. But somewhere in the middle of the game, it goes completely off the books. It's interesting to see.
That's wild.